Hello students, in this video we are given this RC series circuit with this sinusoidal input voltage applied to it, and at the time of application of this signal phi is equals to 0 given. So here we can conclude that at t is equals to 0, when this signal is applied or when this switch is closed, phi is also equal to 0. And we have to find here first the expression for IT, the current flowing here, or you can write it ICT because only one current is flowing there. And secondly, we will find value of phi for which current directly enters steady state. So for the first part, that is to find the expression ICT, we will see our circuit at t less than 0, and at t less than 0 no voltage is applied to our circuit, so this will behave as a short circuit, and current flowing at that time t I0 minus will be 0 ampere because no voltage is there. Now at t is equals to 0, switch is closed, voltage is applied, and what is the value of voltage? That is 200 sine 500 into t, and phi is 0 here. T is also 0 because of this, so V0 is equal to 0 volts. So no voltage is applied at time t is equals to 0 also. So current at t is equals to 0 is equals to 0 ampere. So here we can find the value of I0 is equals to 0 ampere, and that will be same as I0 minus, because capacitor is behaving as a short circuit and current is equals to V by R, and V is equals to 0 here. So this is the value of I0, that is 0 ampere. Now we come to the next step, that is write KVL equation at time t greater than 0, when this signal is applied and switch is closed. So our input voltage is 200 sine 500 t plus phi, and on the right side there will come voltage drop across resistance and capacitance. Now we will integrate this equation with respect to t to remove this integration sign. So this is our equation after differentiating it with respect to t. So this is our equation after differentiating with respect to t. This is our equation. This is nothing but 10 to the power 5. Substitute the values, that is R is equals to 10 ohm and C is equals to 2 farad. Divide each term with 10. So here we will get 10 to the power 4. Now we can compare this differential equation with our linear differential equation di by dt plus pi is equals to q. By comparing this equation, we can find that p is equals to 1 by 20, that is 0.05, and q is equals to 10 to the power 4 cos 500t plus 5. This is our P and Q. We know the solution of this differential equation. Its solution is IT is equals to e to the power minus pt integration e to the power plus pt into q d with respect to t integrated e to the power minus pt. This is the solution of this general differential equation. Now substitute the values so that we can get the solution of our differential equation which we have written for our circuit. So substitute all the values. P is equals to 0.05 and Q is equals to this. So our ICT or IT, there is a single current in series circuit. It is equals to e to the power minus 0.05t integration e to the power plus 0.05t 10 to the power 4 cosine 500t plus 5 plus k e to the power minus 0.05t. This is the solution after substituting the P and Q values. Now we will simplify this. Firstly, we will solve this integration part. Okay, so integration of e to the power at into cos bt with respect to t is equal to e to the power at divided by a square plus b square a cos bt plus b sin bt. Okay, this is the integration of such type of combination. dt is also there. Yes, now put the values. A is equals to 0.05 and B is equals to 500 here. Write down this as it is. ICT is equals to e to the power minus 0.05t e to the power 0.05t divided by 0.05 square plus 500 square a cos bt, that is 0.05 cos 500 t. Write down this phase angle along with this plus 5 plus b 500 sin 500 t plus 5 plus k e to the power minus 0.05 t. Now we will simplify this expression, this transient current expression. This will be cancelled and will become 1. Okay, and yes, in place of q, yes, this will come as a common. 10 to the power 4 is also there, and this will come as a common to both the terms. And yeah, now divide by the square of the coefficients and root of them, that is 0.05 whole square plus 500 square and root of them. Similarly, multiplied by the same number. Why we have divided by this number? Coefficients of both cosine and sine and squares of them and root of them, so that we can introduce another phase with the help of this. So cosine is there, so treat this as sine of theta and treat this as cosine of theta. So we can use another identity of sin a plus b. So here we can get that. Write down this term here. first simplify this. This will be cancelled and here root will come. 10 to the power 4 is there. Square and root of this term is 000025. We can neglect this because it is very much smaller. So divided by 500, this will become 200. And the last term we can write here e to the power minus 0.05t. Okay, now this is, replace this with cos theta. Okay, so our cos theta is 0.05 divided by root of 0.05 square plus 500 square. Similarly, replace this with sin theta, that is 500 divided by 0.05 square plus 500 square and root of that. Okay, so first replace. Here will come sin theta. Sorry, this is cos theta because I want to use the identity sin A cos B. So this is cos theta and this is sin theta. Okay, so this is sin theta. You can take in that way also, but in that case sin A sin B cos A cos B, such type of identity we have to use. So this is the sin theta and cos theta. So here we get the value of tan theta, that is 0.05 divided by 500 and it is equals to 10 to the power minus 4. So theta is equal to tan inverse 10 to the power minus 4 and that is equals to 0.0057 degree. So here we got the value of theta, that is equals to 0.0057 degree. Our second parameter. Now apply the identity, that is sin A cos B plus cos A sin B. So here sin 500t plus 5 was already there plus theta will come here and the value of theta is 0.0057 degree. Okay, now we don't need this. Okay, this is, multiply this with 200. This will come as it is, e to the power minus 0.05t. This is our transient current ICT. Now to find the value of this K, substitute the current at t is equals to 0, which is 0 ampere. So at t is equals to 0, ICT is also equals to 0 ampere. Put these values, 0 is equals to K e to the power 0 plus 200 into sine t is equals to 0, 5 plus 0.0057. What about this 5? It is also equal to 0 at t is equals to 0. At beginning we have seen that at the time of application of signal, phi is given equal to 0. So put this phi is equals to 0. So K is equals to minus 200 into sine of 0.0057 degree and value of this is 10 to the power minus 4. So this is nothing but minus 0.02. K is equals to minus 0.02. Substitute this K here. So ICT is equal to minus 0.02 this much. So this is our expression ICT. This is expression ICT, which is first part of our question. Now we have to find the value of phi for which current enters steady state. For that, put the value of phi so that it will counteract this value. So we will make this whole phase 0. So if phi is equals to minus 0.0057 degree, then at t is equals to 0, what will be our current? ICT is equals to minus 0.02 e to the power 0, that is 1, plus 200 into sine 0 is again 0. So the value of current is this much. If phi is this much, if signal applied with this phase shift, then current will directly enter into a constant value or a steady state value. So this is the way to solve this type of question. Thank you.